A disk of given mass slides over horizontal frictionless surface under action of force F1, which points in the positive direction of the x-axis, and horizontal force F2. Magnitudes of F1 and F2 are given, but I would like to draw your attention that direction of F2 is not given in advance, and here it is shown in an arbitrary direction. The figure here gives the x-component of velocity of the disk as function of time during the sliding. The equation in the problem is to plot y-component of velocity of the disk as function of time if it is given that at initial time this component was equal to 0. Here we summarize what is given and what we need to find. Now let's analyze the problem. We know that forces F1 and F2 are constant, so the net force will be also constant. It means that acceleration of the object will be constant. For constant acceleration, we know that y-component of velocity is given by this equation. In addition, we know that initial y-component is equal 0, so for Vy we have simple equation from which we see that to find Vy we need to find Ay, y-component of acceleration. How to find Ay? First, let's consider second Newton law for this case, and we know that Fnet is the vector sum of F1 and F2, and now we can eliminate Fnet between these two equations and we get this equation for acceleration and forces. Now let us consider x-components of all vectors and take into account that this component is equal F1. So we can rewrite this equation in this form, and from here we can find x-component of F2. To find it numerically, we need Ax. We can use for this the plot which is given, and because this is a plot of velocity versus t, the slope of this plot will give us Ax. To find the slope, we consider the right triangle and take into account that this side is equal 6 meters per second, and this side is 2 seconds, and the slope is tangent of this angle, which is equal Ax, and numerically it is given by 3 meters per second square. We plug in this Ax to this equation, and immediately we will find that F2x equal 1 Newton. Now let's go further and consider calculation of acceleration. Again, we will use second Newton law, but now we will consider y-component of this equation. Y-component is a sum of y-components of F1 and F2. F1 is 0, 0, and we have, replacing Fnet with May, we have this equation for F2y. Now we write equation for magnitude of F2 as sum of squares of x and y component, and from here we can find F2 as this. We know that F2 is 2 newtons, F2x we found previously is 1 newton, and using this equation and these numbers, we can first calculate F2y and then plug into this equation and get AY. Finally, we found equation for Vy, which is a linear function of t. To plot this function, we return to our graph and calculate 2 points using this equation. First point we select at t equals 0. We have, for this t, we have Vy equals 0. And second point, we select t equal 2 seconds, and Vy in this case will be 1.2 meters per second. Now we plot at this point, it is here, and then this point, and it's enough to plot the straight line which passes through these 2 points. So it looks like we solved the problem. However, this solution is incomplete. And at this point, I recommend to stop watching this video and think a little what is missing in our consideration. How to complete the solution. After this, you can continue to watch and compare your thoughts about the additional solution with my solution. Okay, welcome back, and let's continue the solution of the problem. So in the first part, we consider the force F2 as pointed in this direction, and we found x component of this force. But you remember that the direction of this force is not given, and this result actually doesn't depend on direction of force F2. So this component corresponds not only to this direction of force F2, but to this direction also. And we should analyze this case separately. We start with finding this y component of this force using this equation. As a consequence, we have this equation and this answer, because we know both F2 and F2. Then we take y component of the net force. This is equal to 0, and y component of the net force is just MAY. So we can find AY from this equation equal negative 0.577 meter per second square. Magnitude of this acceleration is the same as in previous case, but sign is negative. So y component of velocity is given by this equation, and we can plot this as we did previously. So we calculate initial point taken t equal 0, so this is origin. Then we take t equal 2 seconds, and we get this second point, and we draw the line through these 2 points, and this line represents the second solution for Vy. Now the problem is solved completely. What we can do in addition, we can find this angle between force F2 and F1. It's very simple. We know that the tangent of angle between two vectors is the ratio of y and x components. In our case, it is equal 1.73, and this angle equals 60 degrees. Of course, in the second case, this angle is exactly the same in magnitude.